Melissa, and your attention here. So, the last thing we want to do in integration is volume, but officially in the syllabus. This is the last new thing. Other stuff are something we have done before. The kinematics and differentiation will be brought back again, maybe tomorrow's class. Volume of solid revolution. So we're interested in the volume of a shape formed if functions are rotated along the axis. Let's look at some demonstration here. Let's say we have the line y equals 2, for example. This point is 2. If this line is rotated along the x-axis 360 degrees, you will form what shape? What? Cylinder. Cylinder. Because there will be, it's going to come like this, yes? And then we can find the volume within certain interval. Of course, this line extends indefinitely both sides, so we have to have an interval. So let's say just from here to here, some points B. Then that gives the height of the cylinder, and so is the radius of the cylinder. Okay? Also, if you have your line, like the investigation I asked you to do just now, y is equal to x. If it's rotated along the x-axis, you form a cone, right? Then you are talking about the volume of a cone. Now, these are easy shapes, so to speak. Then what if you have an exponential function, for example? Exponential function, see like that, like this, for example. What if you have a logarithmic function? What if you have a rational function? You know, you get so many complicated stuff. But we have a way of doing it by integral. Have you done the first part, finding the volume of the shape form? You've done that, right? So, the way to do it in integral for a general function is simply to find the integral within those intervals, pi integral those interval of y squared dx with respect to x. So the volume is this. This shape, for example, will have been some non-so-called, not so regular shape, right? Something like this. Understand? And it will be difficult to even, there's no particular formula for such. We can test this because there's no time to go into the detail. We can test whatever you have done here using integral. Okay, actually maybe I'll just show you on the software. Or, okay, let's do just this one. So for this one, you've done this, you've rotated, you got this, right? I said from 0 to 3, so from here to here is 3. So which means the height is 3, right? But what about the radius? The radius is from here to here, isn't it? How do we find the radius? When x is equal to 3, y is also equal to 3. So automatically the radius is also 3. Am I making sense? So radius is 3, height is 3. We're just lucky we have that in this case. So the volume will be pi 1 over 3 pi r squared h, right? So which will be 1 over 3 pi 3 squared times 3. So that is just 9 pi. Is that what you got? So let's put it in the integral and see. So that will be the integral, pi outside, because pi is a constant, that's why it can be taken out. Pi integral y squared between 0 and 3, y squared will be, remember the y is equal to x, right? So y squared will be x squared dx. So that gives you pi, integral of that is x cubed divided by 3, right? Between 0 and 3. 0 can be neglected in this case, right? For the 3, you have 3 cubed over 3, which is also 9. Am I making sense? Similarly, the other one that I asked you to try, y is equal to 3. Let's put that here. Just quickly. You put that here. So here you have 3, y is equal to 3. Automatically the radius is 3. Isn't it? What about this height of the cylinder? Yes, what is the height of the cylinder from that question? I'm talking about number 2. The height of the cylinder will be what? 4. Because I said from 1 to 5. So the height of the cylinder will be 4. Okay? So what is the volume of a cylinder?
It's the area of the circle times height.
Say that again?
Area of the circle times height.
Give me the volume of a cylinder. I'm not going to write area. Please, speak like, okay? Like a mathematics student. Okay? So you have pi, r squared will be 3 squared then times 5. So we get 45, no,
4.
times 4. So we get what? 36 pi. By integral. That will be the integral from what to what? Pi, of course, outside, yes? Speak louder, please.
1 to 5.
1 to 5. So again, y squared will be 3 squared dx. Isn't it? Because y is 3. So that's just pi integral 1 to 5, 9 dx. Which is just pi times 9x 1 to 5. Please no C indefinite integral, please. Am I giving you your test paper back?
Yeah.
Okay. So this will be pi 9 times 5, pi, or pi could just be outside, then 9 times 1. 45 minus 9 is 36, you get the same thing again. Okay? Similarly, we can talk about the revolution along the x-axis. Just like we did on that area, you'll be making use of the inverse function. Because now it's revolving in this way. Am I making sense? So similarly, I'm going to write that next, but I just want to discuss the general idea of what we are doing because of our time. So that will be the integral of x dy. And this a and b must be the limits, the bounds on y. The boundary of the integration, the limit of integration. Am I making sense, please? So, and how do we get this x? Do you remember from area?
You make it the subject.
You may just make x the subject, which is like the inverse function. Understand? And that's just it. Same, oh sorry, x squared, sorry, not x. X squared. Just like we have integral y squared, then this will be the integral x squared within that limit. Okay? Now there's an aspect of this that is not in your syllabus. I hope I'm not too fast, please. Is it okay for everyone? Because the only thing we are introducing is how integration is related to volume. Every other thing we have done before. So I don't see the need why we have to just keep beating about the bush. Okay? The last aspect is when you have two functions, just like we have area bounded by two functions, area enclosed, remember that? You can also have volume of enclosed region. So for example, if you have function y is equal to 5 and function y is equal to 3, okay? This is your xy plane. Say, oh, these two functions, what is the volume of the region bounded by the area that they enclose together? Talking about here. Understand? If revolve at 360, so you will notice you're going to have something like this, and you're going to have something like that. Am I making sense? So you're talking about the volume of a pipe, isn't it? Volume of a pipe, right? How do we find the volume of a shape like that? Normally, forget about integration.
Volume of the outside.
Volume of the outside minus volume of the inside. So it's like simple, just like area. You find the area of the function above, find the area of the function below, and subtract. Same way here. So you do integral y squared, that's the upper function, minus y squared, that's the lower function, dx, and you have your pi outside. That's it. Okay? But I don't think this is in your syllabus this year. But we'll still take some example, like practice, just in case. And this is all about the volume of solid revolution. Before I write concrete examples, I'd like us to look at this. So this is y is equal to x. Okay, I'll send you the link to this GeoGebra. So let's see. Of course, if you change the b, you can see the more you extend the second limit of the integral, the bigger the shape is, right? And you can see it's a cone. Okay, cone. I don't know, something chopped that off. Maybe there's a rat in the house. It's a cone. Okay, it's just the enlargement and reduction. Don't worry. There's no rat in the house. Okay, it's a cone, something like that. No. We need to see you. Something like this. So let's see the integral. This is the volume. Okay, this doesn't have the calculation. It's fine. Let's change the function to x squared. You see? It's a weird shape, I know. Okay, maybe let's change it to, how about x squared plus 1? This doesn't, okay, let's change the limits. Also, you can actually change the limit of integral too. it's not big enough. It's meant to look like a flower, something like that. Okay. I think I have other app that could show us this, but I just wanted. I think this can show me like a different side of it. Look at this one. This is the function x over 2 along x-axis first. You can see if I rotate it. Can you see how that is formed when it is rotated? Of course, I can set the limit from 0. Okay, from 0. It looks like the musical instrument. Okay, these are not regular shape that you would see normally. So this is the function normally on the graph. Okay, now suddenly if we decide to rotate, see what we see. We can take that to the music room. Okay, and if you rotate along the y-axis, this is what you see. Let's say from 0 also. Along the y-axis, this is what we see. Along the x-axis, this is what we see. Understand? The function can be changed. You can have sine. Let's see if sine x will work here. Okay, it does. Let's rotate along x-axis. See, all you have to do is just square the function and integrate, and your pi is outside within the interval. I think it's easy to do. Okay? In our textbook, there are some demo also that we could use to visualize. And you see, this is the exponential x divided by 4. So let's look at it from here. So we see how it's rotating. Interesting shape. Although they have a limit, we can't edit that, but it's fine. This is the one we have just done. Get a cone. Okay. But this time around, it's not starting from 0. Do we know what this is called in math? Something of a cone. Have you had a frustrum of cone? If you have a cone and you've chopped off a small cone, the other part is not a cone anymore. Okay? There's an idea called frustrum of pyramid. So this is a cone, and you cut this part parallel to the base. You're going to look at something that looks like your lampshade in the bedroom. Right? So the volume of this is actually the volume of the bigger cone minus the volume of the smaller cone in normal calculation. But you don't need to worry about that. Integral even makes life easier. Once you know the function that led to that shape, just integrate within that boundary and you are good to go. Any questions? So now I'm just going to write the 3 ideas together. This one, then the y-axis, then the 2 shapes together, and then we start looking at examples on our own, of course. I won't do any example today because of our time, and I believe it's easy enough. Okay? Questions, please? No? All right, great. So let's take this down. So that's the first one. The second will be volume of revolution. Mr. Chen, please take this seriously. Thank you. I don't have all day. Along about the x and y axis. So maybe I put it together. If f of x is rotated, say about the y-axis. By the way, this is in your formula booklet, so no need to memorize. About the y-axis, then the volume is v is equal to pi integral y, not x dy. Okay, so these are the 2 we need to worry about. This one and this one. here. That is, first make x the subjects from y is equal to function of x. Look at the board, everyone. Your formula booklet, 5.17, you have it. No need to memorize. Oh, I said y dx instead of x squared d. Am I getting old? Maybe. So please, it's x squared dy, not x dy. Okay. So no need to memorize. Suppose there are two functions y is equal to f of x and y is equal to g of x. So I said yu as upper function and yl as lower function, for example. I'll just use but this one, we will only discuss about x. We can do similar about y. So you have one function like that. Then you have another function this way, for example. It will intersect too. Okay. Like this, such that they intersect somewhere, such that they intersect somewhere here. Oh, that is one of our visitors. See, the area of the enclosed region, we can find the volume that it will form when it is rotated. So I will call this y upper, I will call this y lower, because it's the one below in that region. Understand? So we might be interested in the volume generated when this part is rotated by around about x-axis 360 degrees. So it's going to go like that. This is going to come like this. Then we're going to have this stuff here again, and it's going to revolve 360. Am I making sense? Okay, so I don't want to go into the details. Okay, so the volume, so I'll just put the limit of integration. The limit of integration definitely is the x-coordinate of the point of intersection. So see, this is A and this is B. The volume of generated by the enclosed region enclosed or the shaded region in this case is volume is pi integral a to b y upper minus y lower squared dx. This is not in your formula booklet, so is it that they do not expect you to know it, or they expect you to use your intuition from these two to just draw an inference here? Understand? I'll check my compressor syllabus if it is there or not, but whether it's there or not, no knowledge is a waste. Okay? Okay. So I'm going to project some questions from your book. We have 10 minutes. You may start looking into them. But does everybody have WeChat?
I think so.
Yes, okay, so maybe I can take a screenshot, put it on WeChat. We could just try a few. The worksheet that I'm compiling at the moment, I just want you to do volume alone for now. Okay, this one is interesting. But you don't have the question. Yeah. Okay, let's just take something from the book. Yes, of course. So let's look at some problem from number 2. I'll send to WeChat, so you can just make use of the WeChat. Yes. If you have your WeChat, or you can just look at it on the board. Question 2. Understand what I mean by YL? The function below, lower. Because from the shape, one is above the other one. Remember, in area, you find the area below the upper function, then you find the area below the lower function, and that gives you the area of the shaded part. The same way the volume generated by the shaded part, just like the illustration I did here, will be the volume generated by the upper function minus the volume generated by the lower function. Because this space in between them will be a vacuum. Nothing is there. Just like in a pipe. Understand? So that's why. I think there's something in the book that... Please, you can start working on 2. Okay, this is y-axis. Aha, look at this. If you can look at this, okay, donuts. Look at this donut. Interesting donut. I know we're all foodies, so we love donuts. So look at that. Can you see this? So there's an upper function, which is the red. The lower function is the green. So you can say, so if you want to find the volume of the donut, it's going to be the volume of the one outside minus the volume of the one inside. Okay, Krista is smiling because I'm saying donut. Come on, Krista. Come on, Krista. You don't have to be like that. Look at this one, for example. You see there's an intersection. And look at the shape form. You see the middle is empty, kind of. There's a vacuum at the center. Can everybody see this? Okay. So just realize that, oh, the upper one is the red and the lower one is the green. So the upper one generates a cylinder and the lower one generates something like, looks like a flower, something like that. So the volume will just be volume of the external shape minus the volume of the internal shape. And that's what we are talking about. Okay? All right. Okay, no, we don't want donuts. So I've screenshot question 2, put it on WeChat. I think it's this. Please just try the question 2. I will send you more later. We don't really have enough time. So I'll take from Y also. In that you can try maybe question 1, something in question 1, the second picture. So please check your WeChat. And this is the donut family. can also do this in the calculator. I will send you the calculator function from the book as well. So when you practice, you check with your calculator, please. I think screenshots on WeChat is better for the calculator than PDF, right? Or you prefer both? PDF is better? Both of them, alright, so calculator. Calculator steps. So, Terry must not miss class tomorrow, tell her that. I want everybody together on the last day. But some people run away.
Last class of the year.
Last class is tomorrow.
Yeah.
What?
Last class of the year. No, wait, no. Last
Tomorrow
physical.
half
Last
day?
physical.
In person.
Last in person.
Physical class.
Tomorrow we have a double. Don't tell me something is happening, they're gonna cancel that.
No, I'm just saying it's the
Otherwise,
last
I'll
physical
report
class of
everybody
the
to the
year.
police.
He's thinking about taking
I'll call the
pictures.
police. Don't worry, Terry will Photoshop you into this one. We'll pretend you're working on that table. So she spilled coffee on our computer. Not food, that's weird. You're supposed to be the one to spill the coffee.
Yeah.
You're supposed to be
The
spilling food.
one with milk and sugar.
How does that work?
That is not good.
That is not me.
I think that's more good.
Oh, yeah.
I can't believe 2026 is going. But we have to let it go. La 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 la.
Here's this time to talk about what to do for the online class.
Aren't you guys going somewhere?
No? Where will we go?
I mean, like for... Oh yeah, we have like 3 minutes. Okay, so let's fix the online class. Saturday, this Saturday is okay to start?
Saturday?
Okay, we can start this Saturday, then we can do like early next week. Alright, and if anyone is having anything to do, because now this is what I thought we would have covered. Look. See, I thought we would have covered differential equation, but we haven't. So I thought during the holiday we could just focus on this. So clearly, by the end of tomorrow, of course, only one period is enough for all this. It's not something whatever. Then I can begin differential equation, but I can only do maybe at most this first two. So I need some time. Hopefully on Saturday we can do more of differential equation on Saturday. Oh no. On Saturday, then hopefully during the holiday we can finish the last part and also do Maclaurin's expansion. Okay? So we need, a couple of days, if that's okay. And also we need to talk about the IA over the break. So even though it's a break, but it's not a break. Because deadline for submission of IA officially is February from the school point of view. And the school give us a deadline. So if you wait till last minute, it's not. So I'm going to be chasing you a lot over that break for your IA. Okay, I know there are a lot of pressure. I know it's a lot of commitment you guys have, but please and please and please, we don't have a choice.